Hello friends, welcome back to Pathogenesis. Sorry for delay in posting videos as we were busy saving lives and taking care of COVID patients. This video is second part of basics of flow cytometry. After understanding the principles of flow cytometry machine, we next move to the uses of flow cytometry in various hematological disorders. But before moving towards diagnosis of different leukemias, we will first understand normal hematopoiesis in the bone marrow. If we know how normal hematopoietic cells behave in flow cytometry plots, then only we can identify abnormal patterns in different types of leukemias. We will also understand about CD markers, which form the basis of flow cytometry and are used to label and identify different types of cells. If this is your first time here, do not forget to subscribe to our channel and click the bell icon so that you do not miss any updates about our next video. Each type of cell in blood has its own unique signature, whether it is a blast, lymphocyte, monocyte, neutrophil or RBCs. This signature is defined by CD markers. No matter how many times we read about CD markers and hematopoiesis, we tend to forget it. So in this video, we will learn to apply CD markers in a practical way so that we can remember them. Learning about CD markers is the key to understanding and interpretation of flow cytometry. So what are CD markers? The immune system works through leukocytes interacting with each other, with other cells, with infectious agents and with other antigens. These interactions are mediated by cell surface glycoproteins and glycolipids. It is these proteins and lipids that define the signature of the cells and are known as CD markers. Antibodies against these proteins and lipids have provided powerful tools for analysis of their structure, function, and distribution. It provides an essential classification for diagnostic and therapeutic purposes and have been used widely in hematology, immunology, diagnosis, and therapy. Flow cytometry takes advantage of these CD markers to identify a cell as a lymphocyte or promyelocyte or a blast. Flow cytometry analyzes each cell based on the CD markers present and number of those cells present in the sample to label it as normal or leukemic. Now coming to the uses of CD markers and flow cytometry. CD markers are critical for the diagnosis of lymphomas and leukemias. CD markers are especially useful for identification of various leukocyte population using flow cytometry. CD marker specific antibodies have been widely used for cell sorting and their identification in flow cytometry based machines. In addition, CD markers have become significantly important for cancer treatment. Some therapeutic antibody drugs have been designed to target cells that have a particular CD marker. For example, rituximab against CD20 for lymphomas and leukemia treatment, alemtuzumab against CD52 for chronic lymphocytic leukemia and T-cell lymphoma treatment. So let's begin with learning about hematopoiesis by studying CD markers on different types of cells in the bone marrow. Stem cells are positive for CD34, 117 and negative for CD38. CD45 is also known as common leukocyte antigen and is present on all leukocytes. Granulocytes express CD13, 33, 11b and 15. Monocytes are positive for CD64, 4, 14, 11b and 16. T lymphocytes express CD3, 7, 5, 2, 4 and 8. T helper cells are CD4 positive. T regulatory cells are CD4 and CD25 positive. Cytotoxic T cells are positive for CD8. B lymphocytes are positive for CD19, 20, 79A and C22. Thrombocytes or platelets are positive for CD41 and 61. Natural killer cells are positive for CD16 and 56. So after getting an overview of CD markers on different types of hematopoietic cells, let's understand normal hematopoiesis and its maturation. A hematopoietic cell during its maturation pathway from a blast to a mature cell undergoes various immunophenotypic changes. Some markers which are already present on a blast or stem cells are lost, while others are gained sequentially during maturation of a cell. Understanding hematopoiesis helps in understanding the maturation pattern of a cell. Only when we understand the normal hematopoiesis, we can make use of flow cytometry to pick out what is abnormal. All hematopoietic cells are derived from multipotent stem cells. This diagram depicts the overline of bone marrow hematopoiesis, which begins with multipotent hematopoietic stem cell. It further gives rise to common myeloid progenitor and common lymphoid progenitor cells. Common myeloid progenitor cells are the origin of mature red blood cells, platelets, neutrophils, eosinophils, basophils, and monocytes. In today's video, we will learn all about granulopoiesis or development of granulocytes. Hematopoiesis begins with stem cells which are positive for CD34 and CD117 but are negative for CD38. Blasts have immunophenotypic profiles similar to stem cells, or we can say that blasts may have one or more markers expressed by the stem cells. Myeloblasts develop from common myeloid progenitor cells. They mature through myeloblast, promyelocyte, myelocyte, metamyelocyte to form neutrophils. Myeloblasts or blast of myeloid lineage express CD34 or CD117 or HLA-DR. And as granulocytes mature, there is total loss of CD34 and CD117. Promyelocytes are CD34 and HLA-DR negative but express CD117. Acute promyelocytic leukemia or APML arises from promyelocytes and has a characteristic CD marker on flow cytometry plots. CD13 and CD33 are expressed by all stages of granulocytes but can be downregulated or upregulated in some type of leukemias where they act as leukemia-associated aberrant immunophenotype or LAIP on flow cytometry. CD15 is expressed from promyelocyte stage to neutrophils with increasing intensity. CD16 is a maturity marker and is expressed in band forms and neutrophils. CD11b is a monocytic as well as maturity marker of the granulocyte series. Now coming to hematopoiesis and development of monocytic lineage cells. Monoblasts also arise from common myeloid progenitor cells. They progress to form promonocytes and finally monocytes. Macrophages are tissue monocytes. Monoblasts are CD34, CD117 and HLA-DR positive. While CD34 and 117 expression is lost during maturation to monocytes, expression of HLA-DR is retained in monocytic lineage cells after blast stage. CD13 and CD33 are expressed throughout maturation cycle, but CD33 is brighter in monocytes compared to neutrophils or granulocytes. Monocytes during hematopoiesis gain CD11b, CD14 and CD64 from the stage of promonocytes with increasing expression to mature monocytic stage. They are also known as monocytic markers. Acute myelomonocytic leukemia, acute monoblastic leukemia, juvenile myelomonocytic leukemia are few of the hematopoietic disorders arising from monocytic series of cells, which we will be learning in upcoming videos. Now let's move next to erythropoiesis or development of RBCs and megakaryopoiesis or development of platelets. Erythrocytes and megakaryocytes originate from megakaryocyte erythrocyte progenitor cell, which develops from common myeloid progenitor cell. Megakaryoblast is the precursor of mature megakaryocyte. It shows CD34 expression along with weak expression of CD41 and CD61. CD38 and CD42 are absent. As they mature, they lose CD34 and gain CD38 along with a very strong expression of CD41, CD61 and CD42. RBC cycle begins from proerythroblast leading to basophilic erythroblast, polychromatophilic erythroblast, orthochromatophilic erythroblast, reticulocytes and finally RBCs. A proerythroblast is characterized by positivity for CD34 and CD117, which are immaturity markers. Later they gain positivity for CD36, CD71 and CD235A. CD34 and CD117 are lost from next stage onwards. CD235A is a pan-erythroid marker and is present across all stages of erythroid cells, whereas CD36 and CD71 are lost on mature RBCs. Flow cytometry utilizes maturation and development patterns during hematopoiesis as foundation for diagnosis for various disorders. After covering CD markers in myeloid, monocytic, erythroid and megakaryocytic lineage of cells in this video, in our next video, we will be covering hematopoiesis of lymphoid cells, including B and T cell development along with their respective CD markers and origin of various lymphoid hematopoietic disorders. If you liked our video, please encourage us by clicking the like button, and if you have any doubts, feel free to ask in the comment section. We will be pleased to answer your queries. To get a version of these tables of hematopoiesis, you can message us on Facebook or Instagram and we would be happy to provide them to you. Kindly subscribe and share our video. Take care and stay safe, and let's meet soon in our next video.